Hello students. Now I have written a question in the board. We will discuss how can we solve it. Let us see. Question is, draw a displacement time graph. Bit 1 when the body is stationary. Bit 2 when a body is moving with uniform velocity. And third question is when body is moving with variable velocity. I have explained that when displacement time graph is parallel to the time axis, then the body is stationary. If displacement time graph is parallel to time axis, then body is stationary. This graph shows that the body is at same speed with the change in time. Time changes, but distance of the body from the observer does not change. Hence, this graph shows the body is stationary. Body is stationary. For second question, when body is moving with uniform velocity. That means body is in uniform motion also. If we take 1 second, here time along x-axis and distance along y-axis, 1, 2, 3, 4, here 5 meter, 10 meter, 15 meter, 20 meter. This is the graph, dt graph for uniform velocity. In every second, body covers 5 meter. In 1 second, it covers 1 meter. In second, it covers 5 meter. In third second, it covers 5 meter. That means the speed of the body remains constant. If the dt graph is a straight line and inclined at an angle with time axis, then the body travels with uniform velocity. This is uniform velocity or uniform motion. And next we will draw when a body is moving with variable velocity. Same take time along x-axis and distance in meter along y-axis. If graph is like this, one second, 2 second, 3 second. This is 2 meter. This is 5 meter. And this is 8 meter. That means body covers all equal distance in same interval of time. So this graph shows the body travels with the variable velocity. Body travels with the variable velocity. And motion of the body is non-uniform. Understand? How can we solve this question? Now in the second question, we will discuss the VT graph and various questions about this. In the second question, we discuss these 4 questions. And to know these 4 questions, to answer these 4 questions, you have to visit my site at the Dilip Paris Club. And I have clearly taught what is the VT graph And what is the nature of Vt graph during the uniform velocity, uniform acceleration, and variable velocity, uniform acceleration? Then we can solve these questions. First question, when a body moving with uniform velocity, we have to draw the Vt graph. I have explained in the previous video. Here we will take time along x-axis. This is the answer for bit 1. And velocity in meter per second. Body moving with uniform velocity. Time changes, but velocity remains constant. That implies if we take here 1 second, 2 second, 3 second, 4 second, here 2 meter per second, 4 meter per second, 6 meter per second, and 8 meter per second. The graph will like this. In each second, the velocity of the body remains same, that is 6 meter per second. If the Vt graph is parallel to time axis, then body is moving with uniform velocity. Second, we have to draw body moving with variable velocity but uniform acceleration. Variable velocity, uniform acceleration. Time along x-axis and velocity along y-axis. The graph will like this. A straight line. If the graph is a straight line inclined at an angle with time axis, then the body travels with variable velocity but uniform acceleration. In Vt graph, if we want to know acceleration, what we have to find out? We have to find slope of the Vt graph. Here, at 1 second, the velocity of the body is 5 meter per second. At second, at 2 seconds, the velocity is 10 meter per second. At third second, velocity becomes 15 meter per second. That means every second, velocity of the body increases by 5 meter per second. So, in this graph, if we find acceleration, then acceleration equal to slope. This is the 15 and this is the 3. 15 by 3, 5 meter per second. Hence, this is the graph. When a body is moving with variable velocity and uniform acceleration. Now, we will go to third question. What is given? Body moving with uniform variable velocity but uniform retardation. Variable velocity, uniform retardation. Here time along second and velocity in meter per second. 1 second, 2 second, 3 second, 4 second. 2 meter per second, 4 meter per second, 6 meter per second, 8 meter per second. And the graph will like this. At 0 second, the velocity is 8 meter per second. At 1 second, it becomes 6. At 2 seconds, it becomes 4. At 3 seconds, it becomes 2. At 4 seconds, it becomes 0. That means gradually the velocity is reduced. When there is decrease in velocity with time, then that is called retardation. So this is the graph for variable velocity, uniform retardation. Now, last one, variable velocity and variable retardation. Variable velocity, variable retardation. We can write also acceleration also. If the graph is like this, then this graph is variable velocity and variable acceleration. We will take time along x-axis and velocity in meter per second along y-axis. Here, velocity does not remain constant and acceleration also does not remain constant. At various point, the acceleration become different. So, this graph shows variable velocity and variable acceleration. Now we know how can we draw the graph, dt graph and vt graph for various conditions. If you like my video, then share, subscribe and like it. In the next video, we will discuss some numericals of this chapter. Thank you.